Hi everybody. Let me get that set up here. Another day, another screencast, February 20th, 2014. My blog, Math Notations, Twitter, at DMoraine, YouTube channel. Be great if you could subscribe to support me doing this, and at the same time leave comments on any of those social forums to give me your thoughts about how you can improve this, how you would like me to improve this, or questions you would like me to also make screencasts for, and that would be very helpful. Let's begin. We have a linear equation in two variables, 70a plus 19b equals 2838, a restriction on a and b, positive integers. You might want to ask your students, what's the significance of that restriction? We would hope someone in the room would recognize that if we only ask for integers, there might be many solutions, if not infinitely many. And without any restrictions, there would surely be infinitely many solutions, namely all the points on the line. Anyway, this could be an SAT type question. In fact, it has appeared on a recent SAT. I've modified it, and it would be a student-generated question, a grid-in. Instead of finding A or B or an ordered pair, find the combination of A and B, A plus B, which is more difficult to guess, obviously, and from a multiple choice point of view. But this would be a grid-in. So let's begin. Since we know that students are comfortable with the calculator, without doing much thinking, most students would probably start using guess, test, revise, substituting in values for A and B. With some number sense, perhaps they would try a value for A like, 50 or 40 or 30. 40 would come pretty close, since it would give you 2800, 70 times 40, and that would lead to a solution. Give them a couple of minutes to work on this in their group, see how many different solutions are generated, and it might be interesting to discuss methods here. It is not a coincidence that 19 and 38 appear in the question. The more advanced the number sense the students have, the more skills and number sense they have, I think the more likely they would see 19 and 38 being connected. So perhaps they would think about 2838. They may not write it, but they might think of it as 2800 plus 38. 38 being 19 times 2, so that's a possible value for B. And 2800 being a multiple of 70. How many of your students would come up with that solution? It might surprise you to find that they could also come up with other solutions on their calculator by a variety of methods, depending on what they plug in for A or B. So we have one solution, 40, and 2, A plus B. They could grid in 42 and they're done. But we're going to go further. We're going to go beneath the surface here, and they may have already arrived at a couple of more ordered pairs, but let's talk about a method for generating these, which they might, it's unlikely that they would have seen this. So we're going to start with our 40, 2 solution, but we're going to reduce 40 by the other coefficient, 19. Then take the value for B, 2, and add the opposite coefficient, 70. Without their calculator, why not ask them how they know that, how they can determine that this will also be a solution? We hope they will recognize when distributing that 70 times 40 and 19 times 2 gives you the current solution, the previous solution, I should say, and then introducing a negative 70 times 19 and a positive 70 times 19 that will offset each other should in fact produce a second solution. 40 minus 19 is 21, 2 plus 70 is 72, and the sum would be 93. I'll bet you that some students would still want to take their calculator and multiply 70 times 21 and 19 times 72 to convince themselves that this really produces 2,838. Anyway, is that just a clever device? Non-intuitive method? Why did we reduce 40 by 19? Why didn't we reduce it by some other number like 18 and then try to balance it on the other side? Well, hopefully you would ask this question and students would respond and say, oh, well, you need the 19 and the 70, so because those are the coefficients given. A different value would not work. Well, now you could ask them, based on this, to come up with a third solution. Let's reduce 21 by 19, getting 2. Increase 72 by 70, 142. The sum of 144. There are your three solutions. This can be discussed further. We could give them other problems to practice on, but this is all about the Common Core mathematical practices, what we want our students to do and how we facilitate it in the classroom, delving beneath the surface, asking them to investigate and abstract and conceptualize the procedures we show them to make sense out of them, and this should deepen their understanding of mathematics. Thank you.